Hi class, in this video we're going to cover chapter 15 in the first book and chapter 6 and 7 in the second book. It's all about file systems. I just want to let you know that I'm doing all this on VM2 because in VM2 I have 3 extra disks for us to work with. So when I built this virtual machine I added 3 blank disks. So the first command we're going to talk about is disk tool. I'm not sure how they got this name, but DF will allow you to see how much space is being used on your system. So if I hit DF alone, it shows me that I have 15% use of the boot partition. Or if I do DF-H, it will show me in human readable format the size. So instead of giving to me in this format, it will actually give it to me in something that we can actually comprehend. So in this particular partition, I used 152 megabytes. We have another tool called DU. If I do DU against my current directory, which is root, my home directory, I can see that these files are using this disk space. If you do DU-H, I can see it in a more human readable format. Sorry, I'm just going to the next chapter in the book. We have a command called list block that will show me all of my devices attached to this machine. So right now I have a loopback device, which is my CD-ROM. So basically what I'm doing for our image is I'm mounting the CD-ROM, I'm mounting the ISO of the CD-ROM for the installation to a loopback device. It's just essentially that's how we mount an ISO in Linux. We have a hard disk called VDA that stands for Virtual Disk A, Virtual Disk B, Virtual Disk C, and Virtual Disk D. And the V lets you know it's a virtual disk. If this was an SDA, it would be the first SCSI or SATA drive. An HDA would be the first old type of ATA drive. Sometimes you might see your CD-ROM as an HDA drive. So you're going to see 3 types of drives mainly. HDA for old ATA disk, SDA, which is the most common, which is SATA or iSCSI disk, not iSCSI, just SCSI disk, and VDA, which will be virtual hard disk. So the first 2 letters tell you whether it's a virtual hard disk, a SATA drive, or an old ATA drive. The last letter lets you know what disk it is. In Windows, we enumerate the disk with numbers. In Linux, we enumerate the disk in letters. So A is the first disk, B is the second disk, C is the third disk, D is the fourth disk, and so on. Now, after the drive letter, A, B, C, D, we have something called the partition number. So if this particular disk has 2 partitions, a 1 and a 2, and it's actually referring to an actual device driver. So let me list this. List long dev VDA. So this is the actual device driver name that I'm pointing to. So I can see that this is a disk. If I do list VDA1, that's a partition, even though it says it's a disk. So we format our disk, and this would be the partition that we're actually dealing with. So right now I have 3 disks, and they're not mounted to anything. VDB, VDC, and VDE. They're not being used, they're blank. And then I have another one, VDA, and that VDA disk has my operating system on it. Hold on one second, I'm going to go beat a cat. Every time I sit down to record, this cat has to go crazy and wants to go outside, wants food, wants something. This cat is like the consummate victim. So just again, this is a hard disk, this is a partition. So I could do a list block and see all of my disk and partitions, or I can run a command called fdisk list, and I can see them there as well. So let me scroll up a little bit so we can see. I did fdisk L, and I can see on my first hard disk I have 2 partitions. One is a traditional Linux partition, one is an LVM partition, which we're going to do in this lesson as well. I have the VDB disk that has no partitions, the VDC, no partitions, VDD, no partitions, and then I have these other disks, these device mapper disk. Those aren't real disk. What those are part of this LVM. So I can make a logical volume manager and then create disk from that. And that's what these 2 mappers are. They're part of that LVM. And lastly, I have my loopback device, which I set up to be my DVD drive. I'm mounting my ISO to that loopback device, and that loopback device, my DVD actually has 2 partitions on it. One blank partition and one partition with the operating system on it. Okay, so those are my current disks. So our goal right now is going to be creating a partition and mounting it to our system. I'm going to show you the traditional Linux partition first, and then I'll show you LVM partitions next. So I'm going to create a partition now. I'm going to do fdisk device VDB. That's my first blank partition. Excuse me, that's my first blank disk. So if I scroll up here, I can see that that disk has no partitions on it. Also, if I look at list block, I can see again that that disk has no partitions on it. Right there. So if I do fdisk-L, it just shows me all of my disk. If I do fdisk with the node-L, it basically takes me into fdisk, and it no longer becomes a command, it becomes a utility. So once I go inside, it shows me a little welcome screen and hit M for menu. M for help doesn't really help students remember. Just think of M for menu. So if I want to see the menu, I hit M. And there's the menu. dodge partitions, delete a partition, um, toggle a partition to be booted. Uh, there's all kind of things that we can do here. So what we're going to do is we're going to create a new partition. This isn't the only utility to use for creating partitions. It just, this one is older than dirt. It's just been around for a long time, and this is the one that I prefer. So when they, right here, we pressed M already. When they say print this menu, they don't mean to print device. What they mean is print it on your screen. So that's the command we just ran. So right now what we're going to do is create a new partition. So we're going to hit N for new. And this partition has already been initialized as an MBR partition because it sees this machine that we're on as a generation 1 machine. If this was a generation 2 machine, it would have created it as a GPT by default. Now we could convert this to a GPT. And the major difference between a GPT and an MBR is a GPT partition keeps track of the partitions by a GUID, a global unique ID, where that's what GPT stands for, GUID partition table. And an MBR keeps track of partitions based on a partition ID. And it's a binary number and there's only two fields. So if you have two binary number, and with a binary number you can either have an on or off. With a two-digit binary number, you could have four possible values. 2 to the 2 equals 4. So with an MBR partitioning table, we can only have 4 partitions. With a GBT partition table, we can have unlimited partitions because each partition has a unique, a global unique ID. And in a case like that, I could have, it's a 128-bit number. So with GPT, we have unlimited number of partitions. With an MBR, we only have 4. Sorry. So if we needed a lot of partitions, I would redo this as a GPT. For this particular lab, I'm going to leave it as an MBR. So right when I hit enter, because it's an MBR, it's going to ask me, do I want to have a primary partition or extended partition? Because it's MBR, we can have two types of partition. 4 primaries or 3 primaries and 1 extended. This extended partition allows me to create logical partitions under one of my physical partitions. So it does give me the ability to create more partitions, but they're not real, they're logical. So it's telling you have 4 free spots. You can only have 4 physical partitions, either 4 primary or 3 primary and 1 extended. So we're going to make this a primary. We can hit P to select primary. And which partition do we want to create? 1, 2, 3, or 4. We're going to create partition 1. Now it's going to ask you what sector, and you need to know the geometry of the disk, what sector we want to put that, start this partition on. And I'm just going to hit enter, just use the first available free sector. Now, you could calculate it, but I really don't think it's necessary to calculate the size of the disk. So it's asking for the first sector and the last sector. So if you want to make a 10 gigabit disk, you would have to know the geometry of the disk, calculate how many sectors you would need, and make sure and you would list the last sector that you need. But no one does that. So they have this nice little utility where we could either put the sector, or we can say plus 10 G, and it will go out 10 gigabits and figure out the sector for you. So we just created a new partition. I could do L to list the partition. No, I'm sorry. L will list the partition types. I want to do P to print my partition table. So far we used M to see the menu, N to make a new partition, L to look at the partition types. If I wanted a FAT32 partition, I would use B. Right now we're just going to create a Linux partition, which is using type C4. By default, because we're in the Linux box, this is the type of partition we're going to create. And then P to show the partitions. So I'm going to hit Q and just exit and redo this whole thing. I didn't make any changes. When I hit Q, it just quits without saving any changes. So I'm going to do fdisk, my disk drive, which is VDB. That's the first available free disk. You don't partition partitions, so you never want to put a 1 there. We're going to create that with this utility. You partition disk and you end up with a partition. So I'm going to fdisk dev VDB. I'm pointing to the actual device driver of that device. I'm going to hit N for new. It's going to be a primary partition. It's going to be partition 1. I'm going to start at the first available sector. I'm going to go out 10 gigs. Or if I just hit enter, it will use the entire disk. Hit enter. I can hit P. See, it's of type Linux. Remember when we hit L and we saw the different partition types I could create? This is a Linux type partition. Hit P to print my partition table. Now if I want to quit, I can do WQ. WQ will write then quit. Q alone will just quit and not save anything. So I'm going to hit M for menu to look at the menu. WQ. So I want to save and exit. When my computer boots up, it reads my partition table. And what happens is, if I create a new partition, my kernel is not aware of it because it only reads the partition table when I boot up. So what I can do is part probe, and that will reread the partition table. So if you try to format your partition and you're not able to, it's because the kernel's not aware of the partition. So what you need to do is just do part probe. If your machine doesn't have the command part probe, what you need to do is reboot so the kernel's aware of the partition. So we're going to create we're going to put a file system on this partition we created. If I do list block, I can now see the VDB disk has a 10 gigabyte partition on it right there. So that's the disk, that's the partition. We don't format disk, we format partitions. And we have a bunch of different file system types we use in Linux. We have an old riser partition scheme, which is no longer used anymore, mainly because the guy who invented it and was the major supporter of it went to prison for murder. So a lot of times they call it murder FS, and Ubuntu used to use it quite a bit. And then we had ext 2, 3, then 4, which we used in Red Hat distributions for quite a while until recently we moved to XFS. It's a file system type. Just like NTFS or FAT32 are file system types you would find on a Windows box, on a Linux box, you could use ext2, ext3, ext4. Those are different versions of ext. Um, you have the old riser file system or the new modern XFS. Not every distro has moved on to FXS yet, but they probably will. So there's a company called E2, and they create a bunch of dist tools. I just typed E2 tab, and we could use E2 commands to create uh, partitions and stuff for an old ext type partition. But right now we're going to use the new file system type, which is XFS. So the first thing we're going to do is make FS. I'm going to hit a dot, then I'm going to hit tab twice. So if I wanted to format it ext3, ext4, ext2, FAT, Minix, which is like an old Unix type operating system, MS DOS, um, FAT, FAT32, or XFS. The command is really mkfs-t. One second, my screen is kind of frozen. -t, and then you would put the type XFS here. Let me just switch virtual machines. Okay, ACE is kind of wigging out, so I'm going to pause for a second. Okay, we're back. Okay, so the command is mkfs-type, and you could do XFS, ext4, whatever partitioning scheme you want to use. But just to make it a little easier, instead of having to type -t, we could do this, and it's a lot easier than typing this. It's the same result. So we're going to make FS of type, sorry, let me explain that. Make FS, make file system. I pronounce it make FS, but it's MKFS. Make file system. So I'm going to make a file system of type XFS, and the device that I want to format is VDB1. Again, fdisk we put in the disk, and makefs we put in the partition. So now it just created a partition on that. Now we formatted that partition we created on VDB1, on VDB. The next thing we want to do is give it a label. You know, when your C drive, how you have this name Windows right here? Well, that's a label. So we're going to do that same thing for this partition. So I'm going to use a command called xfs admin. And when I do an uppercase L, I'm going to call it data. Actually, I'm going to label it data. And dev sdb vdb1. So that's the label I'm going to give it. In Windows, when you create a partition, you mount it to a drive letter like D, E, F. In Windows, and that's how it is on Windows. In Linux, we mount it to a folder. This is not a rule, but kind of a convention. I like to make the label match the folder I'm going to mount it to. So I want to mount this to the MNT data folder. So that's the label that I'm going to give it. If I do XFS underscore admin, a lowercase l, it will show me the label. So uppercase L sets the label, lowercase l displays the label for a given partition. Sometimes, guys, when you hear something, they'll call this a device. That's fine. The dev folder is where we keep all of our device drivers. So when you're dealing with partitions or disk, you just point to the actual device driver. So the old ext file systems, I wouldn't use this XFS underscore admin command. I would use the E2 label command. So I'm just kind of explaining how you would assign a label in the old ext file systems. For XFS, this is how we do it with the XFS admin command. It can do a lot more than just this, but that's the only thing I'm covering in this lesson. So now I'm going to make a directory called mnt data. If you remember one of the first chapters we went over file systems, and I kind of covered what the MMT directory is. It's like a directory for temporary file systems. So for this purpose, I'm just kind of using it as a permanent file system. So every time this machine boots up, I want to mount dev vdb1 on this folder. So when I go into that folder, I'll be in that partition. So I'm going to make the folder first. I can't mount a partition to a folder if the folder doesn't exist. So you have to make the folder first. So list mmt, and I can see I have a folder there. So I'm going to do mount the type of file system that I'm going to mount is an XFS file system. The device I want to mount it to, the folder I want to mount it to is MMT data, and the device is dev vdb1. Sorry, I thought I was going to mess those up. I got the order wrong. I want to put the device first, then the mount point second. We call that a mount point. That's where I'm going to mount this partition to. So to mount something, we're going to mount -t what file system it has, so it knows how to mount it, the device I want to mount, and the mount point I want to mount it to. So if I do df-h, I can see that dev vdb1, which is 10 gigs, is mounted to MNT data. If I go into that directory, I am now in that partition. If I go into this directory, boot, I would be on that partition. So here I'm on VDB1. Here I'm on VDA1. And you're going to have to trust me, because the next thing I'm going to do is, remember I talked about that LVM? So if I go here, I'm on VDA2. Let me try to explain that. VDA2 has been repartitioned as LVM disk. So I created a partition called VDA2. Then in that partition, I created two LVM type disk or LVM type partitions. And I'll explain these a little bit later. And that's what this is referring to right here. So here's one partition, which is dev vdb1. Here's another partition. This is dev vda1. And here's another partition, dev vdb1. Excuse me, vda2. So it would be like jumping from the C drive to the D drive to the E drive. That's how we get between partitions. The end user, it's transparent to them. When they save something on a different partition, they don't know whether it's a different partition or a folder on the same partition they were on. So if I go cd etc, I know from experience that this is under this partition right here. I can't highlight with this mouse pad. So etc is under that partition. So if I go boot grub 2, I hit tab right there. I know I'm on the dev VDA 1 partition. Here I know I'm on VDA 2 partition. Here I'm on VDB 1 partition. It's going to take you a little bit of time to understand that, but because a lot of people are so used to drive letters, but you need to understand the different types of mount points and when you go into it, what actual partition you're on. So I'm going to type the mount command. So if I type mount alone, it shows me my mount points, and I can see dev vdb1 is mounted on MMT data. I can see that VDA1 is mounted to boot. So over time you'll get that. There's a lot of stuff here that I'm not going to go over in this class, but those are the important ones that we're dealing with. So right now, if I reboot this machine, this will disappear. Not because the partition will go away, but there's been no mechanism in place to tell the system, when you boot up, automatically mount VDB1 to MMT data. So what we're going to do is we're going to edit a file. When my system boots up, it reads this file and mounts those partitions to the mount points that I specify. This is etc fs tab. That stands for file system table. All these files that end in tab are essentially like a column table. Each column has a different function. So if you want a file system to mount automatically at boot, you have to list it in here. So I'm going to hit vi space etc fs tab. So I'm going to go down to the end and hit O. The first column is going to be the device driver, like dev vdb2, dev VDB3, things like that. Or it could be the UUID. Every partition gets a unique UUID number, not to be confused with the GUID. And I could mount by that UUID number. Or I can mount by the label. I could say label. I'm going to press escape. Press Q, colon Q, so I don't save anything. Colon Q bang. Listen, if you have a typo in this file, your machine won't boot. It's important that you have no typos in this file, because this is the file that is read to boot the partitions. If you mess it up, it won't be able to boot the partitions or mount the partitions. If it can't mount the partitions, it can't load the OS. So you need to be very careful and have no typos. So in this first column, you could either put the device driver, the UUID, or the label. So I'm going to hit a lowercase l. And remember, I put the label as MMT data. It's hard to see, but the second column is the mount point. That's where I want to mount it to. The third column is the file system type. A swap file is a temporary file system used as memory. XFS is the file system we're using. And how do I want to mount it? Do I want to mount it as a certain user account? Do I want to make it read only? Do I want to mount it as, like right here? I had to specify it's an ISO loopback device. Here I'm going to mount it with the defaults, meaning mount it as root, mount it as read-write. I could turn on ACLs, I could make it read only, I could mount it as a different user account. For right now, I'm just choosing the defaults. So I can hit 0 space 0. These last columns is when do I want to check the disk and how often do I want to tune the disk. You want to be very careful with this. If you have a 64 terabyte disk array attached or just a bunch of disk attached to this Linux box and you have it tuned the disk at boot up or check the disk at boot up, it might not boot for 2 days. So I'm going to turn it off so it doesn't check or tune the disk. We'll do it manually when it needs it. So right here, I'm just going to mount it as, I'm going to mount that device with that label to the MMT data mount point. It has the XFS file system, and I'm going to mount it with the default. That's a typo right there. And I'm not going to check or tune it. Now, here's the thing, guys. The width of these columns are for humans. I could have 1 space, 10 spaces, 10 tabs. It doesn't really matter to the computer. So I put these tabs here to make it a little more human readable. But it could be 1 space and that would be fine. So the space is not important. It's just the columns are. And you have to also make sure you don't touch any other line, because if I mess this top line up, my system will just hang. So you need to be very careful with this file. Any typo will prevent your machine from being booted. So I'm going to show you how to mount by label first. So I'm going to press escape, colon, WQ to save it. I'm going to unmount the partition that we created. I'm going to unmount it first. Dev VDB1. if I do df-h, I can see that it's no longer mounted. So before I did mount, the type would be XFS, the device driver would be dev sd vdb1, the mount point would be MMT data. So what I'm going to do is just do this. I'm not going to supply all the information that mount needs to mount that partition. And by doing so, I'm going to force the mount command to read at the FS tab to find the information. And that does two things. First, it mounts the disk, which is obvious. Second, it's going to read the FS tab and make sure I have any typos. If I had any typos when I run this command, it's going to give me an error. I'd rather find out the error now opposed to when I'm booting up the system. So what I like to do is run the mount command with missing data, so it forces it to read FS tab. If it mounts it, that means it was able to read the FS tab. And it mounted it no problem. If I do df-h, I can see it found the device driver and found the mount point. It was able to mount it. Because all that information that I didn't supply, it read the FS tab to find. I'm going to go back into the FS tab. I'm going to show you how to mount it by device as opposed to by label. So I'm going to erase this. I'm just using the X key. Sorry. I'm going to hit I to go to insert mode. I want to type in dev sdb1. So here I'm going to mount it by device driver. Before I mounted it by label. I'm going to hit WQ to save and exit. I'm going to unmount the disk. I can now mount the disk by specifying the device driver, like I did last time, or the mount point. Either will unmount it. Then I'm going to do mount again, MMT data. I'm not telling what type of file system it is. I'm not telling what the device driver is. For it to find that out, it has to read CFS tab. Sorry, ACIT again. When I get that message, I just switch virtual machines. So I'm going to hit enter. And I have some sort of typo. Oh, I see my typo. I'm so used to dealing with physical hard disk, not virtual hard disk, I put SDB. Now, if I had did this and rebooted the machine and didn't test it first, I wouldn't be able to boot. I would have to do a bunch of stuff to get in there to fix this error. So it was kind of nice that I made that error. So I'm going to go back into SCFS tab. I should have typed a VDB, not an SDB, because it's not a physical hard disk. So I'm going to hit Shift R. No, I'm not. I'm going to press Escape. I'm going to highlight the S key. I'm going to hit a lowercase r and then a V. A lowercase r replaces one character. Press escape, :WQ. Now I'm going to try mount again. Maybe not. So I was able to mount it. If I type df-h, I can see that it found the device and mounted to that mount point. Or I can do the mount command alone and see it as there as well. Okay, so far I showed you how to mount by label and how to mount by device driver. So now I'm going to show you how to mount by UUID. Let me do this first before I go in there. I have a command called block ID. If I hit enter, it shows me all the UUIDs for every device. So there's the UUID for VDB1. If I do block ID vdev VDB1, it just shows me that one device. If I do S, lowercase s, UUID, and the option is value, it just shows me that just the value of this. So I'm asking for the UUID, but I don't want to say UUID equals, I just want the value alone. And I'll show you how that comes in handy. We need to put this in SEFS tab. So if you can remember that, then verbatim type it once you get in the file. Good for you. I can't. So I'm going to show you a little trick. I'm going to go into, and you need to kind of memorize this. I'm not going to say why, but this is be something that you really need to remember. So I'm going to go into SEFS tab. I'm going to go to this line that we added. I'm going to delete it. So right now I'm not in insert mode. So what I'm going to type is go shift : to go into command mode. I'm going to do R bang. If I do this, let me refresh your memory. If I do bang, block ID, that's going to run a shell command called block ID. So it's going to exit VI, run the shell command, and then bring you back into. So there, showed me my shell command right here. And when I hit enter, it'll bring me back into VI. So it allows you to execute a command while still in VI without having to leave VI. But if I do read bang, not only will it execute a shell command, but it'll take the results and insert them inside of your file that you're dealing with. So I'm going to do block ID. The device is dev VDB1. I want the UUID, but only the value, not the equal sign. And there, it just inserted it into my document. I'm going to do Shift A to go in insert mode at the end of the line. So that's my UUID. My mount point is MMT data. My file system type is XFS. I want to mount it with the defaults. First column is either the device, the label, or the UUID. The second column is the mount point. I don't care if the columns align with the other entries, just as long as it's the second column. It can be separated by 1 tab, 2 tabs, 3 tabs, whatever. The third column is the file system type. FAT32, whatever you formatted it as. The next column, the fourth column, is who do you want to mount it with? Who do you want to mount it as? Read, write, things like that. Turn on ACLs, turn on this function, whatever you want to do. Right now, we're just going to use the defaults, which means mount it as root, leave the ACLs turned on, and it will be in read-write mode. The last two columns is when you want to check and tune it. So I'm going to press escape. I'm just going to show you that command again. Colon to get down to the command mode. R bang block ID. I say block ID, but really I'm typing BLKID dev VDB1. I want the UUID and just the value. I don't want the whole UUID equals phrase. And it will insert the UUID for you. I just hit DD to delete it again. I don't want to have two entries. I'm going to hit Shift : to go into command mode, WQ, to write and quit. So I'm going to bang U, which will run the last command that started with U, which was umount. And I want to do bang M to run the last command that started with M, which was my mount command. No, it wasn't. So I'm going to type history. I want to run 149. So bang 149. I have another typo. So I'm going to go back into TFS tab. Guys, I forgot to put UUID here. Hit insert, UUID equal. If you don't specify label or UUID, it assumes it's a device. So I forgot to specify that this is a UUID. Press escape. WQ to exit. Bang M to run my mount command again. There it ran mount MMT data to df-h. And you can see that it mounted it successfully. Okay, guys, I'm going to stop this video now. I want to break this up into 3 different videos, just so you can do it in 3 different sections. You don't have to do it all in one sitting. So far what we did is we learned some basic disk tools, and we learned how to create a partition, a traditional Unix partition or Linux partition, and mount it to the system. So I want to do one more thing, which is reboot the machine and make sure that partition is mounted automatically. Oh, guys, and while we're waiting, look, I looked this up. They don't have a space there like I did in my command. You don't really need the space, but I think it's a lot easier to read with this space. That's what we just did, and I got this from the Red Hat website. So you're in VI, you need that block ID, you can just run this command and it'll pull it in for you. So it's colon to go into command mode. See, we're in command mode. Read bang, then you run your command, and it will take the results of that command and insert it in your document for you. So let's go back, open up a shell, and let's see if that got mounted. I'm going to sign in as root. Run the df-h command. I can see it's mounted right there. No, that's not it. Mounted right there. If I wanted to and not look at all that data, I could do this and grep for data just to filter out all the other stuff. And I can see it got mounted successfully. Or I could mount and grep for data. And again, there's my mount. Oh, incidentally, I'm glad I pulled this up. Here's what default means. Inside our SCFS tab, when I say default, those are the things it mounted as. Mounted as root, read write, rel time, security label, extended attributes, attributes to, I know 64-bit, and I'm not turning on quotas. So that's what default means. Okay, guys, that's it for this video. I'm going to make the next video as soon as this one is uploaded. Thank you.